Complex. I'm Simon Wansborough. I'm a PHINZ board member and a builder who likes to build good houses. Um, I think a lot of you were part of the webinar last week with Jason and Benji. Benji from Stark is with us here again today. Thanks, Benji, for sponsoring these webinars. If you were part of the last webinar, then that was with Jason, then that was pretty technical, pretty full on from that respect. But I definitely learned a lot watching that. Today we're going to look a bit more at the practical side of Windows and types of Windows and installation of them from a builder's perspective. This webinar will be made available, recorded to view on the 2nd of June. Questions, feel free to put questions in the chat box if you'd like to, or just note them down yourself, because like I said, we will be having kind of discussion session at the end, so plenty of time there to ask questions and throw ideas around and that kind of thing. So yeah, again, thanks to Stark for sponsoring. So just going to share my screen. Windows are vital but complex. So first up, Benji, would you just like to tell us a little bit about Stark and what you guys do?
Yeah, that's amazing. Thanks, Simon. I'm coming through all right?
Yeah, I can hear you loud and
Yeah,
clear.
cool.
Hopefully everyone else
Yeah,
can.
gold. Yep, that's cool. Yeah, so for those of you who haven't bumped into us, we had our sort of foundation and standard aluminium windows, from the 80s. And it wasn't until the last maybe decade or so we began to have realize just how bad the aluminium was. Because we're an independent window company, we were free to innovate and to look around the rest of the world and discover just how far behind we were. So, and bringing higher quality windows to New Zealand is a big part of what drives us. So we are a Kiwi company, as it says there, been around since the 80s and around 70 staff. And we currently, we're probably most well known for our UPVC offering, but we do have a commercial division which is doing some pretty big thermally broken aluminium systems too, the likes of Raynars, and some of those are actually suitable for passive house. We've never done a passive house in aluminium, and it's partly because the cost of those systems from us at the moment is pretty high, but they have some impressive characteristics, and we can probably get into some of that a bit later on.
Cool, thanks, Benji. So Windows are always the problem.
Yeah, actually, I thought that slide was hidden, but while we're here, it's a slide. If you want me to talk quickly to it,
Yep, go for it.
it's showing the relationship between, I guess, thicker and thicker and thicker insulation, and you get this diminishing returns kind of thing, and it's a really key passive house principle, I suppose. At about R6 or let's say R5 or R6. You've got excellent insulation, and going more insulation than that actually starts to not do much, and your designers would know this. Now, the reason we kind of talk about it, and so this graph across the bottom is R values from like 0 to 7, and across the top is how much heat is lost through that element. And so this doesn't matter whether you're talking about walls or windows, it all falls on the graph somewhere. And why we talk about it is because windows with R values of, let's say, less than R1, they lose exponentially more heat than you expect. So that's part of the kind of the physics behind why they are such a big hole in the envelope, and why they're the first place to look for, your heat loss gains, or yeah, it's just quite an interesting lesson in insulation. And I think that's where Passive House really sits. It's that well-optimized zone where you're not spending actually too much on insulation. You're not going to R10 walls or or beyond. It's just at that perfect sweet spot where the physics is all working.
No, thank you. Um, Here's a wee slide just from some of my own photos, some thermal imaging photos taken from outside of a non-thermally broken aluminium suite in a house in Christchurch. And you can just see, obviously the brighter yellow, the hotter it is. So you can see how much heat is leaking out of that house through those windows. So a good example of how crucial it is. And just completely aside from what we're talking about, but if you have a look at that, left-hand photo, the bright orange line along the bottom, that's an uninsulated concrete slab. Um, so yeah, not good.
Wow.
So some of the things we're going to be talking about is how we can make Windows better. So there's a few things there we're going to talk about. Different types of windows, different types of glass, um, double glazing versus triple glazing, and also recessing the frames insulation. Um, so here, Benji has a slide just looking at different window frame materials. Benji?
Yeah, it's and I've only just got smiley faces because a lot of the devil's in the detail, but globally, those three between thermal aluminium, UPVC, and engineered timber, they're the three that are generally compared. This slide used to have a cold aluminium column as well, but I figured I could delete that for this particular audience. None of this is fixed in stone. So there we've got thermal performance. Well, thermal alley is medium, UPVC's better, engineered timber's best. That can vary depending on the exact product, but that's a rule of thumb. And certainly, if you pay, the cost plays a big factor too. You could buy you could buy thermally broken aluminium windows that were the best in the world that may outperform the others, but they might cost 4 or 5 times more. The embodied carbon is also a bit of a wild west. I probably won't get into that at the moment, but obviously timber has the best kind of characteristics there. Tricky to compare, of course. Operational carbon, as we know, that's basically tied exactly to thermal performance. So kind of, once again, we've got a medium sort of better best relationship there. Cost also, hard to know. Although globally UPVC is the best bang for buck. So the cheapest window that can perform well would be a UPVC one. That's partly why that's a product that we bring to the country at the moment, because we want to be able to make high performance available to everyone, as many people as possible, certainly. And UPVC is kind of the best way that we saw to get there. Aluminium windows, which are Passive House certified, will be costly. You can import them, which saves a little bit of money, but there's still a premium price point there, and they're a little bit trickier to get airtight just because of the way they're joined, all that sort of thing. And of course, timber we know is fantastic, but often does come at a cost. So, and part of that's in the manufacturing. Like with UPVC, we can automate that machinery to get them made, and that brings the price down. Whereas timber's still quite a bespoke manufacturing process. The availability in the Passive House space, sort of hard to know. You could dispute any of those. You can buy any of them from various outlets. So you could say the availability is reasonably good across the board. Design flexibility also. I've had someone rightly challenge that I had low on timber there, because you can make anything out of timber. So in a way, the design flexibility of timber is good as well. Toxicity we probably don't need to talk about. It's a bit of a complex topic, less important in the passive house space, but it's to do with the supply chain and yeah, the various environmental considerations of that supply chain. So kind of haven't really said anything there, but those are the key sort of considerations when we're choosing different window frame materials. The slide was initially built, I think, for a more generic architectural audience, and it would be fair to say that by the time you strip out all the windows that you couldn't build a passive house with, so you're only talking high performance windows, some of these sort of ratings that I've given would probably change a little bit. You might have some
Yeah.
comment on the different window frames yourself, Simon.
Um, yeah, I think, what's detailed there is pretty fair as far as, we all kind of think pretty much everyone agrees that timber's the best from a whole lot of reasons. Maybe the area that it's not the best is that there is some maintenance involved, whereas with the other two, any maintenance is very, very minimal. I think the thing to note there with the UPVC is that there's different grades, different profiles and stuff with that, which alters the performance. So just
Yeah,
because it is PVC doesn't mean that it's necessarily going to perform really well. You can get
yeah,
some
yeah,
that have a lot less chambers or a lot more steel or whatever, and therefore
yeah.
they're not going to perform as well as some of the others.
Aluminium's certainly the same in that boat. I mean, you could buy a thermally broken system from a local Kiwi manufacturer that's incredibly low performance, or you could import one that was fantastic. So
Yeah. And this slide is talking to that exactly. So here on the left, you can see more of a New Zealand style thermally broken suite with a little greens thermal break there that you can see. And then you can compare that on the right to something more like what Stark will do, or some other manufacturers in New Zealand. Weather Shield does a very similar one to that, and you can just see the difference there. Whereas on the right hand side, the black section is the thermal break, so it's huge um, compared to the little one which is more of a New Zealand style on the left there. Just out of interest, that left-hand photo is a photo from APL Centrifix system, which helps to reassess that thermal break in line with the insulation, which definitely does make a difference. Righto, so now we get more into how we install the windows to make sure that they perform as well as they can. So back to you, Benji.
yeah, it was an interesting one, and Jason touched on this in the last webinar for anyone who was there, and I think it was his words that obviously, sorry, just before I get into that, but obviously hanging the window frame out into the cavity like so many, or like E2AS1 is not, going to work. You've got a huge thermal bridge there, and your insulation layers are misaligned. So to get that out of the way, we understand that the very best position is dead central on the wall, or at least central to your insulation layer. What we found is that makes the flashings and the install quite a bit more complicated, or let's say bespoke. If the window is in the exact middle of the wall, or back 50 mil from the front face, then you get a bit of variation in that dimension. So sometimes it's back 50 mil and sometimes it's back 30 and sometimes it might be back 70, which means that all your flashings out from the window to over the claddings are all custom, or customized on site, and there's just a bit of complexity there, and that adds a bit of cost and a range of things. So what Jason said, I think last webinar, was you get 80% of the benefit by at least bringing that window frame back in line, so the front face of the window frame is in line with the front face of your wall. And what we found is when you do that, you simplify your flashings and things a whole lot. So it's a bit of a balance, and sometimes obviously with the passive house, every little bit counts. So sometimes that last 20% might be critical. But if we can get that 80% gain by bringing back to kind of the middle option there, which is the frame faces flush with the thermal envelope exterior, we can provide a much more cost-effective window and flashing detail and still get 80% of the gains. So that's kind of where our default detail, which we've tested, is sitting. But then, of course, you know, some jobs will need a little bit more than that. And if you're going to be doing custom flashings anyway, you can push the window right back to the middle of the wall, align those insulation layers perfectly, and you just get that last top 2 inches of performance.
Yeah, just a side note, here we've got a reasonably small group with us today, so like I think that if anyone's got any questions or anything they want to discuss as we go through, just feel free to jump in, yeah. So turn your camera on, turn your mic on, and we're more than happy to have this as a bit of a discussion rather than just the two of us talking to you.
Yeah, if anyone's got any experience or commentary on window position, it would be good to hear.
Anyone got any thoughts about this slide that they would like to share or questions they'd like to ask? I think everyone's muted, so if you are trying to talk, just unmute yourself.
I might have to say something controversial, Simon, and that'll get everyone piling in.
Please do.
It's the next one on ESL.
Yeah. Here we go. The ESL. Should it be at the front or the back or both?
Yeah, surely there'll be some opinions on this, but obviously our default is a rear ESL. That's kind of in the code, and that gets us started. Now, what we know is that the ESL is actually the most critical element of the water tightness, because if it's airtight, then there's no air moving through the system, and when air moves through the system, it brings water with it. So as soon as it's airtight, you go a long way towards securing your water tightness as well. So we have the air seal on the rear, and then of course a lot of people would want an air seal at the front as well, so you got kind of 2 layers of air tightness, which is perfectly reasonable in a passive house situation. So then the debate normally rages around the sill at the front. So you can see our detail here has a little 5mm jog, which means that it's kind of open to air movement at the front. The point in that is not to be open to air movement, it's for any potential, you know, it's not a standard drainage path, but it's for any potential water that ended up there anyhow underneath the window would be able to dry or drain out the front and ultimately get back to a dry state. Now, some people would say, no, you're better to completely seal, head jam and sill, front and back. Don't let any water get in there at all. But it just poses that risk to say, well, what happens if the window fails somehow and leaks down into that cavity? Then it's totally sealed and it can never dry, which is also not good. So I actually found a pretty interesting video of the guy from the US, Matt Ritzinger, and after debating this topic a couple of years, I watched this video and he said, well, when it's in a high risk situation, he leaves the front bottom seal out. And then when it's in a safe or lower risk situation with big eaves and, not so much exposure, he fully seals both. And I thought, well, that's pretty bloody genius, isn't it? He uses his brain and where he thinks there's a risk, you let it drain, and where there's not, you seal it right up. So a kind of a bothist approach was pretty smart, I thought. But I'd be really interested in anyone's opinion on that.
I've got my opinions on that, but let's see what anyone else has got to say. Oh, who have we got here?
Fire away, Simon.
Okay, so yeah, I tend to agree with what you said, Benji. I think the when you're talking about that risk, how you talked about, if it's high risk or low risk, a lot of that to me is dependent on what type of joinery you're using. I think if you're using aluminium joinery, then the chances of leakage through the unit itself is reasonably high. Whereas if you're using PVC, then with its welded corners and stuff, then that risk is, to me, is very, very low.
That's
Um,
true.
I've got I've got a good example of that. We've built ourselves well, it's not on wheels, but it's not, I don't know if it's a tiny house or not. A very small house we've built ourselves, and fairly over the last couple of years. We're just kind of doing it, as we get time and as we get money. And we had a couple of aluminium window units that we thought, well, we'll just chuck them in because we've got them, and then at some point we'll change them over to PVC. Um, so I installed them, as I've been installing PVC for many, many years, um, recessed back so that the aluminium was pretty much flush with my ply bracing on the outside with my weather wrap, um, taped all around, top, sides, and bottom on the exterior. And then we were carrying on building, and my wife said to me one day, "Where's all this water coming from?" And we were inside, and there was all this water running down the frame, and I'm like, "Where's that coming from?" Like, the window's completely sealed.
Mm,
We didn't have all the cladding on at that stage, but it had its head flashing on. So I'm like, it's got a head flashing. It's completely taped all the way around. Where's the water coming from? And after a bit of poking and prodding and figuring it out, it was leaking through the joins in the aluminium. Um,
yeah.
so perfect example of it. It depends on what you're using as to what that risk is going to be, and
Yep.
therefore whether you should leave that bottom open on the exterior or not.
Yeah, yeah, that's a very good point. And the thing with aluminium is it's mainly, glued and screwed or maybe crimped and with a bit of glue and it leaves the factory watertight. But by the time it's bounced around on its way to site, you get it in the hole and you fix it off. There's a bunch of stresses that come on the frame. And then, of course, as it expands and shrinks in the sun and the cold nights, you'll end up with it, might even be half a mil gap in that mitre, and that's all it takes. You'll lose water through there, you'll lose air through there, and that you'll also lose your acoustic performance through that little gap. So definitely a risk factor there.
Anyone else got any thoughts on that?
Yeah, look, I might ask the question. Can you hear me?
Yep, we can hear you.
Right, lovely. Sorry, I'm Tom.
Hey, Tom.
Lobbing in from Australia. Look, are you guys considering low expansion foam in that rough opening between the frame as a weather seal, an air seal, or are you excluding anything in that rough opening?
Yeah, so from a building code perspective, we would have a backing rod, and we would have some expanding foam in there, um, as the air seal.
Yep.
Um, so majority of builders in New Zealand are gonna do that. Um, Personally, I don't think an expanding foam is going to create or does create a very good air seal. especially when you see what happens to that foam once it's exposed to a bit of moisture over time. If there is any moisture, it tends to just fall apart.
Yep. Yep.
So so um, so using a tape on the inside, I think, is a much better form of for that primary air seal, and just using, you know, um, using generally whatever form of insulation you're using in the rest of the house around the jambs and head. So just poking in insulation or whatever around those spots. The question then comes to, what do you use at the bottom if there is going to be moisture and stuff there? Obviously, you're not wanting to use bats or whatever. So using some other form of insulation, whether it's XPS or whatever, at the bottom there, to me is the best option. So allowing in your rough opening size for some XPS or similar type, you know, insulation that can take the load of the window, and putting that with the window sitting on it and then taping, to me, is the best. Yeah, is what we do, and I think, personally, I think is the best option.
Yep. No, fair enough. Look, I suppose my investigations after the fact of pretty much any rigid insulation in that rough opening, it's going to leave a gap, and that's really pretty clear when you start looking closely. This is in passive house world, so really being finicky about it, but nonetheless, just the fact that there is even a couple of millimeters gap, the thermal bypass is sort of there and real. So and particularly the seal, of course, and look, probably that's acceptable. It's got to be durable first and foremost, and so the small additional heat loss is there, but what can be done? So look, I guess along the same lines as Matt had suggested, no eaves, higher exposure site, worse climate, err on the side of caution, and give it a 5% gradient in the sill framing anyway, and expect that there will be water in there one day.
Yeah, thank you.
I think when we did a bunch of soul searching on that, and yeah, I fully agree with Simon. But because it, like I said, the air seal is the most critical component of the water tightness. We were basically too afraid to recommend foam as an air seal, because if that fails, then all sorts of stuff will fail. So we currently I've shown a tape there, but wet seal is also quite a common detail that we're beginning to use. But in terms of stuffing the that little gap, we did some modelling, and actually, if it's modelled as a still air cavity, and it's only a small gap, that still air is actually not as bad as you might think. And then if you, I think it's kind of this 80-20 rule, you get reasonable gains from making that air a still air cavity. And then our second recommendation would be, as Simon says, to poke it full of potentially rock wool, which doesn't deteriorate if it does get a bit of moisture on it, and it still continues to perform somewhat. So our default recommendation is kind of nothing, and then to go up a step would be to poke it full of rock wool.
Yeah. Yep. Good.
Anyone else got any thoughts on that?
Julie, I think, has said, depends what proof the Building Consent Authority would require if you were to tape the outside of the sill. Yeah, that's a good point. It's not often well understood by building consent authorities, and it's pretty well recognised probably in New Zealand in the industry of that, having that open, and there's a chance that a building consent authority may be a little bit freaked out by it if it was sealed shut. if that's what Julie was meaning, I think.
I'm just trying to figure out why I can't see the chat box.
I've got a little button down in the middle of the screen at the bottom that says chat.
Yeah, but when I'm sharing, I can't see any of that.
Oh, I see. Yeah, yeah.
Yeah. Anyway, but you can see it, so that's all good, Benji. You can keep an eye on those. That'd be great.
Yep.
So just another slide here. This is a pro climate detail, so it's showing exactly what we've been talking about already. And so showing some form of rigid insulation underneath the window. It doesn't actually say what it is, but showing that kind of concept. And I think from one of the things to point out here is ProClimate is very pushes the concept that air seal needs to be connected to your weather barrier. So your weather barrier needs to wrap around into your window, and then your primary air seal needs to be connected to that, and then your air tightness is then connected to your primary air seal to make everything all completely make sure that no moisture can get into the framing space if it does get in there. Flashings. Benji's spoken a little bit about flashings already, but we're going to talk in more detail about flashings.
Real quick, so I'll just interrupt. I think my
Yep.
laptop battery might die, so if I drop out, I'll come back on my phone.
Okay, all good. Thank you. So flashings, especially for recessed windows, need to be carefully designed. Some designs look really good, but they're not that easy when you actually come to make them or install them. So from a builder's perspective, having a really good look at the pre-consenting stage, what those details are, and thinking about how you're actually going to do it is very, very important. And then obviously consider using a window manufacturer that has proprietary flashings. Funnily enough, just like Stark. But Stark's not the only one. There are other people out there who are doing that. And it just makes the whole process a whole lot simpler if if you have flashings that are specifically designed to work with the windows that you're using. As Benji was saying, if you're got a bit of a bespoke recess, then sometimes you can't get away from having to do something custom, but just really pay attention to the details before you get into it. Benji, we've got some details of your flashings here. Benji gone. I think Benji's died. He will hopefully come back and join us. So as you can see here, not my area of expertise, these slides, but showing the different sizes of head flashings that Stark has to suit different types of cladding and different setbacks from the cladding. Another one we all might just hope that Benji jumps back on pretty soon, because these are his area of expertise. So we'll just jump forward a bit while we wait for Benji to get back on. Make your choices early when it comes to windows. So windows are a very crucial part of modeling. They need to be considered nice and early in the process. So you don't want to be in a situation where, especially for a certified passive house, where everything's been designed and modeled using a particular window, and then for various reasons, generally around cost, it's found that those windows aren't going to be suitable. So I always like to get the designer to give their thoughts on what windows are going to be used, and then get some indicative pricing for those windows, and share that with the client so we can make some decisions on that before all the modeling's done. So we're not having to go back later and go, well, those windows are too expensive, we can't use them, let's use these ones instead. Oh, hang on, but that means that the modeling's not working out, so then we need to change something else, or we need to change sizes, or we need to beef up insulation, or whatever we need to do. It's so much easier if that's been considered early on in the process. Hi Benji, we'll just jump back here
Yeah,
to your flashing.
yeah, cool. Thank you for that. Sorry about the delay.
All good.
Yeah, probably the only message there is yeah, as you said, a proprietary flashing system. Our one is separate to the window, which means that we've got a bunch of different sizes, so we can kind of handle a bunch of different claddings from right down to 9mm plank, all the way up to obviously brick or weatherboards on a 45mm bat and that sort of thing. And everything else remains the same, just the cladding size the cladding and flashing size change. So we've found that to be to work reasonably well. The one thing we haven't done a huge amount of yet is that same flashing kit on an externally insulated wall. Although it can be done, that might be another topic. Actually, I haven't seen as many passive houses with external insulation as I would have expected. But the window details, begin to change it a little bit. Install details change a little bit once you go external insulation.
I think do you have some details of that in your other?
Yes, I think there are some. Yeah, that's right.
Yeah, yeah. So we can have a look at those later.
Yeah, that'd be good.
I think that external insulation is slowly starting to gain some traction, but
yeah, I've seen it actually more often on non-passive houses than passive houses for some funny reason. But there we are.
sliding doors and air tightness.
Yeah. So obviously, any sliding door in a passive house is a risk factor. A lot of designers and maybe you've got a comment on it would leave sliding doors out entirely. I think more and more though, obviously New Zealanders love a good sliding door, and more and more the technology exists to make a sliding door that actually can kick the goal. Only sliding doors, not stackers, though I should be at pains to point out. You can buy airtight stackers, I've heard. I've never seen one. I've never sold one. They would have to come out of Europe. The interlocker junctions are the problem. So where those panels pick up on each other, pretty tricky to make those into a properly airtight system. So we've got 3 doors, and it's just worth kind of understanding. So the lift and slide door is kind of the traditional airtight door. If you were to import any passive house joiner, it'd be a lift and slide door that they sent. They were probably invented in the 80s, if not the 70s. So it's old tech, but it works. They, as designed, there is absolutely no known air leakage pathway. So if it's built perfectly, it'll be more or less perfectly airtight. If your lift and slide door does leak a bit, it's because of some kind of misalignment or manufacturing defect or seal that's not quite right, something like that. However, they tend to, be at the top end of the price range as well. Certainly, ours are. Big, strong doors that do the job well, basically. Coming down from that, we've got what we call the smart slide door. Now, that's a kind of a European innovation. It, rather than lifting up and down off the rubber seal, it actually moves left and right, or moves like in and out off its rubber seal. From a manufacturing point of view, it means that we can everything's fully welded rather than welded on our standard automatic machines, which makes it faster to make, which makes it cheaper. So it's probably our best seller. It's cost effective and it's airtight enough for a passive house. It can do up to like 2.6 meters high, which is, reasonably good, and up to 2 meter wide panels, which is also reasonably good. Now, the trick with it is there is a known air pathway through that door. It's through the drainage slots, kind of goes across and up the interlocker, and out. It's quite a complicated pathway, but it does exist. So there will always be a tiny amount of leakage through that door. Now, we've done quite a few passive houses with the door, so we know that it's, as long as everything's accounted for, it's all good. But if we saw a set of plans with like 3 sliding doors on a smaller house or even a mid-sized house, we would probably say, look, we're concerned about putting 3 of these doors with known air leakage in one house. Either we're happy with 1 or 2 doors, or change to the lift and slide door because we know that it's perfectly airtight. And then of course the bottom door, the Vario slide door, is not airtight at all, really. It just runs on brush seals. So there's something, and I've just got a comment from Julie. Lift and slide door in our home has brushes between the door and the fixed panel. That's true, Julie, but it also has rubber seals which you can't see. So the brushes are visible, and they are primarily there for extra protection and for water deflection, I think they call it, deflection for those brushes. And then tucked away in the interlocker, where it's very hard to either see or get your fingers, there are 2 rubber seals which butt together when you close the door. So I can confirm that the lift and slide door is a very airtight door.
So what about bifold doors?
No, hard no. Well, from us anyway. We do bifolds, but they're very hard to make them airtight. Maybe there's a system. Maybe there's someone out there who does an airtight bifold. I would be pretty nervous of it. Bifolds generally, as you'd know, Simon, maybe are tend to be a bit more finicky. They can droop if the head drops at all. They can jam. In the main, in my experience in the industry, is window guys and builders tend to stay away from bifolds, and architects and homeowners love them. That's been my kind of experience.
Yep,
So
I'd agree with that.
yeah, trying to get one airtight would be a real battle, and not a battle that I'd probably personally try to fight.
Yeah, I think from my perspective of as a builder trying to build nice airtight homes is when looking at these things, it's looking at the big picture of the building and going, how easy is it going to be to make the rest of the building airtight? And how, if it's going to be a certified passive house, how tight is our air change margin? It's like, has it been designed down to where the point where we have to achieve 0.3 air changes per hour or whatever, rather than 0.6 to make it all work. And looking at that big picture and going, well, yeah, if there's a sliding door and it leaks a little bit, it's probably not going to be an issue because there's a bit of fat in the calculations versus everything's super tight. So therefore, I'm going to be pretty reluctant to agree to put a sliding door in.
Yeah, that's very interesting. Yeah, and look, we've done plenty of homes with no sliding doors. I think French doors are a good option if you want that sort of 2 meter wide opening. But the French doors are very airtight.
Yeah.
So and you can throw them both open, you know what I mean, and you can still get a reasonably decent opening.
Yeah.
So yeah, we've done a lot of homes with French doors, I think, which is just a safer bet if you are close to the line.
Yeah, I quite often say to people who want these big stacker doors or massive, huge, sliding doors, I'm like, I get the want for the indoor outdoor feel, but you can achieve that with glass, so you can see through it, and you're only so wide, you don't need
Yeah.
a 2 meter opening to be able to walk through.
Yeah.
Even if you carry a tray, you're not that wide. So, there's different ways to skin a cat. Um,
Yeah, I'd also
so
say on a
yeah,
bi-parting sliding door, so like a 4 panel where the two in the middle move outwards, that's a way of obviously getting quite a lot of opening space. Um,
yeah,
from an air tightness point of view, we sort of see that as three doors. Like the interlocker junction is the leaky part. So so you kind of got three junctions there, the two interlockers and then the one in the middle. All of those three junctions are basically where the door will leak. On a single slider, you've only got one interlocker junction. So that's, you go from one to three when you go to a bi-parting door. But it does give you a nice big opening. So that's just how we count it from an air tightness point of view.
excellent. Anyone got any thoughts or comments or questions around sliding doors? Anyone had any sliding door installs that have gone bad or gone really well? We did one project where we had some imported timber windows with a lift and slide door, and I won't say who made them, but the windows were fantastic. The windows were really, really good. I was really happy with them. But the lift and slide door was horrendous. We had all sorts of problems with getting good air tightness on that. Um, we got there in the end, but there was a lot of faffing around getting it right, replacing seals, those kind of things. We talked about that. Just one thing we haven't really talked about, and I don't think it's in our slides either, Benji, is glass and different glass options.
Yeah. Yeah,
Uh,
that's a good point. It's a huge topic, and it's probably almost worthy of its own webinar. But um, where to start? Um, yeah, what double and triple is kind of easy for most people to get their head around. The low E films once again get a little bit trickier. Um, I'll just tell, well, one thing I can say, because it's really topical for me at the moment, and we touched on it last time, was you can't, and Jason talked about it as well, you can't always you can't always fit the glass that you want into the frames that you're buying. And the Aluplast 8000 frame, which is our kind of default, sorry, 4000, which is our default, has a 41 millimeter pocket for glass. And actually, that doesn't give you much space. By the time you've got 5 or 6 mil glass, 41 mil, you run out of room on 41 mil quite quickly. So a really nice piece of triple glazing, you want about 50 to 56 mil. And most systems, or many systems, can't handle glass that size. So that's a bit of a trap. And what happens if you have a big picture window? Let's say 2.4 meters high, and let's say you're going 2.4 wide as well, and you're in a very high wind zone. Now we must put 6 or possibly even 8 millimeter glass in that to meet the New Zealand deflection standards. When we put 8 millimeters in there, that makes us even fatter in terms of the glass, and then all of a sudden sometimes you can't fit that single pane. The rest of the house might be all right, but that one big picture window may not be able to fit into the frame. And one thing I've also noticed, and I will just say this, in terms of importing windows and doors, the Europeans do not have the same standard as us when it comes to wind resistance and glass thickness. We get a lot more wind because we're basically an island in the middle of the ocean. So we've seen a lot of import window quotes, and everything's just like the whole house top might be 4 mil glass. Might work in the middle of Europe where they don't get too windy, but if you install that in New Zealand on a storm, you'll see the glass begin to, it won't even shatter, but it'll move in and out in a really disturbing way. If it's at night time and you're inside, and I have seen this, all the lights that are reflected in the glass, when the glass bows in and out, the lights start to go crazy in the reflections, and you will get a bunch of complaints from your homeowner. So the glass thickness is kind of something that you have to watch out for in New Zealand, and it's really determined by the size of the pane and the wind zone, and you can run out of space pretty quick. So that's one trap that has certainly caught us out before. And the other one I was just learning from the local manufacturers, Viridian this was, we normally put the low E on surfaces 3 and 5, and that's how we run most of our calculations. But for the South Island, Viridian have said they will only put the low E on surfaces 2 and 5. And now that's something to do with heat buildup within the DGU and potential cracking and whatnot. But it caught me by surprise because I just wasn't aware that was a thing. So I don't know if you've ever heard of that before, but the glass companies themselves have an opinion on which surface the low E should go on for heat buildup reasons, as opposed to any other technical reasons. So that's something that is probably worth doing a bit more research on.
Yeah, that's an interesting question, because in passive house circles, I often talk with builders and stuff, and there's a lot of confusion as to which surfaces that low E coating should go on. So it sounds like it just got even more complicated trying to figure out where that should be.
Yeah, it is a tricky one. I think it's actually mainly to do with solar heat gain. Or put it this way, which surfaces you put it on mainly affects the solar heat gain. It doesn't really change the U value or the insulating value. That should stay pretty. In fact, I ran some calcs yesterday, and it seems like that stays exactly the same if you change one from surface 4 to surface 5. But the solar heat gain value will change. And what that means is that actually, once you master it, you can choose which surface to recommend that it's on based on the solar gain demands of your passive house. So if you need more solar gain, you can switch the surface there, maybe from 2 to 3, or from 4 to 5. Or if you need less solar gain, you can switch it the other way. But as I just said, we need to be a little bit careful, because sometimes the glass manufacturer will say, no, we won't warrant it that way around. We will only warrant it the other way around. So it's definitely that's one of the most complicated topics.
Your previous discussion around sorry, my mind's gone blank for a second there.
Thickness, glass thickness.
Yes,
No.
yes. Thank you. Around the thickness. We've had that issue ourselves, exactly like you described, where I'd taken my own advice and got the designer and the client together to choose which window suite we were going to be using fairly early on in the process. So that was all good, and we'd worked kind of with that the whole way along. And then when it came to it, very, very close to actually before the windows were going to be manufactured, we realized, well, the window manufacturer realized that they couldn't actually fit the glazing that was required to meet, so the house would meet certification. And so then we had to go back to the drawing board and choose a different window supplier. So we ended up we were going to be using a local supplier, and then we ended up having to import windows to get the glass to fit. And obviously, when you're changing from a local supplier to an import, then you're mucking up your time frames.
You are.
So,
It's definitely it's a gnarly one. And the other thing I'd say and this is sort of confusing back the other way, is that the locally going from double glazing to triple glazing, if you do buy local, does come at a bit of a price premium. We talk about roughly another $300 per square meter. But if you are importing, there's not much difference at all between double and triple glaze pricing. But then it comes with that double-edged sword, because often that quote doesn't have the right thickness, and there's a whole bunch more complexity all baked in there. So yeah, it's glass is a big one, real big one.
Yeah, so that point you made just then was what I was going to bring up next, around the difference in cost between triple glazing locally and imported. Is there starting to be movement in that locally?
You mean bringing the
is that
cost down for
can
triple?
we expect to see that price coming down? Yeah.
Look, I think so. That both Metro and Viridian, and I'm not sure about AGP, but certainly Metro Christchurch is pumping out a lot of triple glazing now, and Viridian's doing more and more. And look, they'll probably ride the wave of making a buck while it's a little bit rare and in high demand, and they can charge a higher price. We saw it with Low E, the classic. It's just the commercial stuff at work. But before H1 changed, you paid a heavy premium to buy Low E, and they were obviously probably sitting on a reasonably good margin, but also they probably didn't have that much stock, and they could charge for Low E. And then once H1 changed and the whole market demanded Low E, even the cheapest window suppliers were supplying with Low E, that price just collapsed. We probably lost $150 a square meter out of the Low E price, which is probably cutting the price in half, just about. And that now we're buying Low E double glazed at excellent rates. The whole market is. But I reckon they're still, because triple's just a bit still at that early stages, the price is still holding up there. And I'm afraid I probably can't say that it's going to come crashing down anytime soon.
Yeah.
But once there's a bit of competition from offshore, like if if there is, one thing we can do is make the frames locally and just import the triple glazing. That's another trick, and that can be cost effective, but you still got a fair lead time and potential risk of breakages, that sort of thing.
Yeah. You do that? You have done that?
Yeah, we have done that. Yep. Depending on the project, I would recommend it in certain circumstances, but not every time.
Yeah. Cool. Anyone got any thoughts around glass? Double glazing, triple glazing? No. We talked about that. So, just got some ideas for discussion for people to chat about, share experience. So I find that I definitely learn a lot sharing ideas and thoughts with other builders and learning what other people have learned from. So some thoughts there around what we could talk about. Which brands of windows have you used? Have you imported windows, and how was that experience? What methods have you used for installing flashings and the pros and cons of those? Have you had any issues getting the required performance for the right cost? What would make window choice and installation easier for builders? Because I'm sure Benji's all about making it easier for us. And
Absolutely.
and any other thoughts or ideas to share. So now's your chance. Jump in, have a chat. And we can see what comes up. Can you see this chat box still, Benji?
Yeah, Tom's just asked Glass, have you any experience or of difference in quality of cleanliness between locally made IGUs and imported?
Sorry, I'll
I
clarify. Yeah, that's dust and fingerprints. So I've been involved in a couple of projects where, and it's not particular one manufacturer, it's just the difference in, I guess, yeah, the more humans and the more handling, the more risk of any kind of contamination there is. And I guess it seems I haven't really seen that so much with stuff coming out of Europe. So yeah, where it's maybe
yeah,
more automated. Yeah.
I'd agree with that. I would say the local glass is pretty bad, and the imported glass tends to be a lot better.
Okay. All right. Yep.
Yeah.
No, I imagined it wouldn't have been too dissimilar, but yeah, just kind of wondered.
It's probably just a volume thing, like some of these European factories have spent the last 30 years pumping out millions of square meters of glass, and their processes are so refined, whereas out here it's just there's not so much volume, there's not so much standardization, not so much automation, and we see that in the quality.
Yeah.
Not too bad, and I think they're getting better. And I think actually processing low E helps. The quality controls you need in place to process low E are quite high, whereas if it's a non-low E glass like they all used to use, you can do that on pretty basic machines, and you don't have to pay all that much attention, and you can still ship it out to the client. So now they've all moved to low E. We've seen a uptick in the quality of fingerprints and dust and all that sort of thing.
You're great. All right.
Yeah, I agree with what you guys have been saying, and that with my experience, I've never ever had any issues with imported glass, but have had quite a few issues with locally made glass, either dust, or we've had a couple of instances where you could see where the suction cups had been on the glass. So they
Yeah.
obviously,
We had
Oh, sorry. I was just going to add further. I've seen a couple of commercial projects where glasses, I guess, perhaps inadvertently, in a couple of units been reversed, and that just hasn't come to anyone's attention because it's just not a usual quality control that people are thinking to compare. It's just doors reversed compared to the windows that they're adjacent to. Anyway, just yeah, interested to know if that's something special.
yes. Since we've gone to low E, I think most of our suppliers have started putting a sticker on the outside. That's a glazier's issue. When it's a clear on clear double glaze unit with no low E, it's never mattered before all that much which way around the glass went. But now it's crucial. So all of our IGUs now come with a big green sticker on the outside saying, glaze this side outside.
Right.
And that seems to have solved most of that issue. Just a funny story on that. We had one instance where it was a customer telling us the story that they had a piece of double glazing, and on a frosty morning or on any cold morning, on the inside of the glazing, this handprint would appear. And it was kind of a condensation handprint. But by the time the sun came up, the handprint would disappear again, and there was no way that they could clean it off. So every cold morning, a ghostly hand would appear on their glass and disappear again, which was pretty disconcerting, I think, for them. But yeah, kind of a funny one.
anyone else got any things they want to talk about? No, what we might do is and I find the right page. Just give me a moment. Um, trying to find. I'm just trying to find your those other slides you had with all those details, Benji. Just give me a second.
Oh, yeah.
If you've got anything to chat about while I do that.
Yeah, maybe there'd be oh, you did right. Any comments that anyone could make about how to make it easier or what their current pain points are. I know that, back in, let's say, 2018, 2019, one of the hardest things about building a passive house was the windows, and it's probably still true, but we've got a few more options now. But I'm sure in the audience there's still some pain points around windows, so would be really pleased to hear any complaints anyone's got, or things that the industry could do to solve some problems. And if not, we'll assume that we've done a perfect job of solving everyone's window problems. It's the only conclusion I can come to. Yeah, I don't have these details were actually presented mainly to an audience that was concerned with weather tightness, not concerned with performance. But the whole industry, including the councils and whatnot, is all a wee bit apprehensive as one word, or up in arms as another word, about obviously recessing these windows because of the leaky building crisis. Everyone's pretty tentative about them all. Just sorry, Simon, I'll chuck it in now. Now my phone's about to die, so if and when it does, that'll be the end of me. So thank you in advance. But yeah, all these are a bunch of details sourced from around the industry of jobs that have been consented. And now when you look through them, some of them are really horrible from a weather tightness point of view, and some of them are not bad. But I guess the message is, if you are recessing that window, you need to do so very intelligently from a weather tightness point of view. And that's not always what's happened. So you can see here, and the worst things to watch out for is obviously an aluminium or a standard Kiwi thermally broken aluminium frame, like you can see there. And then if you just pull that back, it's exactly your experience, Simon. Pull that back into the above the framing. I guess there's an old saying, I think someone said that there's two types of windows, ones that are leaking and ones that haven't leaked yet, something like that. But you've just got to really assume that every window is going to leak and then make a plan to handle that leakage water. So I can't quite see, but it looks like there might be an aluminium sill tray under that window.
Yeah. Well, yes, there is. Have you frozen, Benji? I think Benji has left the building. Yep. So luckily we got through everything we wanted to present today while Benji was still in the world with us. Benji is on Waiheke Island in his car about to make a presentation to some architects, which is why he was having those issues. So
sorry, Simon. Like, this is just got a question. Just one of the details in the previous drawing. Sorry, my camera. I don't have a camera, sir. But just in relation to fixing into the metro panel, I saw that the window frame was fixed into the metro panel. Is that possible? Is there any issues with that? Or is Benji the person to answer that question?
Just let me go back, see if I can.
I think it was not the previous slide, though, one before that, had the metro panel on the inside.
Yeah, so this one here.
Yeah,
Yeah, so
that's it. I just see the window, like just the window liner, like it's fixed into the metro panel. Is that like what type of board is that? Or
yeah,
is
to
that,
be honest, I don't know. And these are just a whole lot of details that Benji rummaged up just to
yeah,
kind of talk about and look at what's good and what's bad. So Metropin is not something that I've dealt with personally. It looks like there's a timber block around the top edge of the panel that
yeah,
but
so you got a
the
bit there,
windows
yeah.
attached to. But yeah, it's not something I can provide any expertise on. I'm sorry.
Okay.
Um, so yeah, like Benji was saying, the crucial part is our sill, and making sure that we allow for any water that does get in there, even though we think it might not. It's yeah. I mean, personally, I used to always tape on the exterior all four sides, and now I don't. I tape the two sides on the top, and I leave the bottom open. But obviously, I'm completely taped, completely air seal on the inside. So I think that we've covered what we wanted to cover today. Um, we've still got a little bit of time, so if anyone's got any things that they would like to talk about, questions that they'd like to ask, ideas they'd like to share, then go for it. And otherwise, if not, then we will sign off. Okay. Thank you for joining us today. I hope that you learned something. Thank you to Benji, even though he's left us, for sponsoring both these webinars, and also providing us with a lot of expertise and information today. As mentioned, this video will be available online next week. So unless there's any last questions come through, which it doesn't seem like there is, thank you very much and enjoy your Thursday evening.